So the talk is called a Skeptic's Guide to Functional Style JavaScript, but we've got a theme going on here that I didn't know about beforehand, and we found this really cool dragon backstage. So now we've changed the title of the talk to Slaying Your Functional Dragons. I don't know. If you've been hanging around the JavaScript community for any length of time at all, you've probably heard about functional programming and the functional style of JavaScript, and it is the only way that you should be writing your JavaScript. The problem with that is I'm the guy who has an OOP Gang of 4 design patterns in JavaScript course, and I'm reluctant to board the functional programming train for a lot of reasons. But every time I talk to somebody, I get this statement. In JavaScript, functions are first-class objects. Have you heard this before? Yes. You know what my response to this is? Functions are first-class objects. It's right there in the phrase, right? So there's a lot of benefits here, but we're not pure OO. I know you can throw tomatoes at me later, but prototypal inheritance, all that stuff. But I like the object-oriented stuff, and so I kind of had to get on board with this idea. So the first thing I want to do, just real quick, is let's set the groundwork for what is functional programming. And the best source, always, to find definitions for anything is Wikipedia. Okay, so Wikipedia says this. In computer science, functional programming is a programming paradigm. We're all on the same page. Okay. A style of building the structure and elements of computer programs, totally still cool, right up until we get to this, that treats computations as the evaluation of mathematical functions. So I was a math major in college. End of my freshman year, I took Cal 3, and then I switched over to computer science because I don't like math. It's just so right there, I'm not happy. But it ends with this statement, and if you've been doing JavaScript for any length of time, and avoids changing state and mutable data. In JavaScript, like, we can't even keep our types the same, let alone the data involved in the variables. So it doesn't work to me. So this is why the talk is called functional style. So functional programming in JavaScript is not a thing, right? Functional programming in Erlang or Haskell, or yeah, that's fine. Functional programming in JavaScript doesn't exist. But we can apply a functional style that might help us get a little better. What's interesting is every time I talk to people about this, oh wait, hold on. So Martin, who created Scala, said this: the programmers in that segment like functional programming because it makes code clearer, better structured, and prevents many classes of errors. The interesting thing about this last phrase, prevents many classes of errors, is because functional programming languages have what is called a compiler. That if you're doing things you shouldn't be able to do, it actually says stop it. JavaScript does not do that. If you change something that's immutable in JavaScript, it just changes it. It doesn't care. It just works. So every time I talk to a functional programmer or a functional style JavaScript programmer, I get this phrase. And you even heard it in the introduction, right? Pure functions are awesome. My question is always back, why? And I was having lunch with a guy in Kansas City, and his phrase was, because they're pure. I mean, how can you argue with that? Right? Pure functions are beautiful. I mean, when you can get a function to be pure, it's like this magical thing. Okay. Side effects are evil. How many of you want to interact in I/O in any way? Right. You obviously do. So that's a side effect. Right? I would contend that interacting with the I/O is not an evil thing. And I'm not alone. The problem is a lot of people, they talk about how awesome functional programming is, but they can't articulate why. But I had a conversation not too long ago with this guy. So if you're going to tweet at any point, tweet at Nate Taylor and say, hey, at Nate Taylor, thanks for straightening John out. He's a Elixir guy, and we were talking about functional programming, and he's like, yeah, you're thinking about this too hard. which I found very interesting, because the bit flipped for me in a very interesting way when I started thinking about this. So think about this for just a second. You cannot avoid side effects, period. You can't, because you have to interact with I/O, right? You've got to do some things. Not all functions are pure, because if you can't avoid side effects, not all your functions can be pure. And not everything has to be immutable. However, functional style, this is what he said that changed fundamentally my understanding of this. Functional style is about using less brain power and making things simpler. Is that your understanding of functional style programming, like coming into this talk? What if I said you have to think less and things are easier? Like that doesn't go with what we've been told, right? But I am telling you, as the guy who hates functional programming because I'm an OOP guy, this clicked for me. I'm going to give you some examples of why, but here's the thought. Functional style is about small, composable things that fit together. A lot of times, let's go back. A style of building the structure and elements of a computer programming. More importantly, the style of building the elements. We're going to talk about how we build elements in a functional style that fit in the overall big picture. As OOP developer, I think of system, right? You've got system thinking. You're trying to think of the whole big thing, and then you think about what your objects are. You think about how your objects interact. You think about all of these different things, and you're thinking about the big picture. What sometimes we forget about and we don't stop and think about very clearly is the little picture. The 2 lines of code here and there that potentially could cause us problems or make us think harder than we need to think. And the reality is, you've got to think about both. So what I'm going to do is we're going to walk through some code, right? We'll just walk through some code, and I'll kind of give you some examples of how this works, and then we can talk about it. Arrays. How many of you use arrays in your programming? If there's not a lot of you, then you're lying. Okay, how many of you are morally opposed to hand raising? So I got more here. Usually I get 1, Corey. I had 4. So you don't have to raise your hand for the whole rest of the talk, but the rest of you, I expect feedback. Okay, so you use arrays. So if you want to do something with an array, not just in JavaScript, but across the board, we use this thing called the for loop. How many of you have ever written a for loop? Yes, okay. So I'm just making sure we're all on the same page, right? So how many of you have seen code that looks like this? So I've got a list of numbers, and I put a comment in there, so my next question will be easy. Like, what's going to print out in my console.log? Just guess. You're not going to be wrong, I promise. But you're thinking about this pretty hard. What's it going to be? 2 through 6. 2, 3, 4, 5, 6. And how do you know this? How do you know this to be true? Right, so I'm looping over the array. For each item in the list, I'm adding 1 to it, and you can just read the comment if you really want to. And then console.log list, and I have this. The interesting thing about this, or this is a very simplified example of things that become very complicated very quickly, but so the idea here, though, is you've got 2 things you're trying to pay attention to right here. The 2 things you're trying to pay attention to right here are this, the iteration code. I've got code that governs the iteration over my array. And then I have code that governs what I'm doing with my array. So I've got these 2 things that are very tightly coupled. I've got iteration code and I've got worker code. What if we could start to pull this stuff apart so that I don't have to pay attention to multiple things at one time? And that's ultimately where we want to get to with functional programming, functional style programming, is I don't want to think about more than one thing at any given time. I want to think about one thing that's pure, it's self-contained, nothing else, and that's it. Okay, so here's what we're going to do. In JavaScript, we have these cool little functional style helpers for arrays. So list.map, what does map do? Who uses map? Right, what does map do? Ultimately, it iterates over an array and then applies a function to it. Isn't that ultimately kind of what this was doing? Right? I'm iterating over an array. So what if I told you you never had to write a for loop again? Yeah, that's kind of where we're getting, right? Stop it. List.map will iterate. And there's a bunch of these. There's list.find and list.reduce, and we'll talk about reduce here in just a minute. There's all of these cool little helper things, and then you just pass into it a function. So this is now our iteration code. This looks a little bit better than what we had before. So what were we doing with each item? We were adding one. Generally, you're doing more than that, right? But I don't want to have to explain a whole lot of code to get you the idea, so bear with me. Yes, this is simplistic, but we're adding one item to a list. What we're going to do with map is we're now going to introduce this concept of a pure function. I don't care if anything else in your code is a pure function, this will be pure. Now, what is a pure function? Real quick, in computer science, a function may be considered a pure function if both the following statements of the function hold true. Two things very important here. One, it always evaluates to the same result, given the same arguments, period, no exceptions. If you call this function with 1 and 2, you get the same result every time. Function add a, b, that's a pure function. Math.random, pure function? No. Why? Because it returns something different every time. That's the whole purpose of math.random. Don't go functional style on random, because that doesn't work. It's not what you want. The other thing for a pure function is this. Evaluation of the result does not cause any semantically observable side effect or output, such as output to I/O devices. Not everything's going to be pure. Not everything has to be pure. But in this case, when you're mapping, when you're doing a map over an array, no side effects. Don't start writing to I/O every time you map. For a lot of different reasons, but the most important one for this talk is because it's one more thing you've got to pay attention to, and we don't want to have to pay attention to it. So let sum equal 0, function add a, sum, not a pure function. This requires more brain power to figure out what's going on because not everything's right there. Stuff's up above, right? And we don't want stuff up above. All right, so why pure? Less things to keep track of, less brain power, but most importantly, it's not a rule. You don't have to have it be pure, but it's a good idea. Okay, so here's what you end up with. I have a pure function, item, return item plus 1. Is that a pure function? Yes. Is it clear what's going on? Yes. However, this is 2017. It's not like 10 years ago. We don't use the function keyword anymore. Now we do this, right? Arrow functions. Who uses arrow functions? Do you know why you use arrow functions? Ah, OK. That's fine. I'm not going to explain it because I don't have time. But and then if you do this and Corey does your code review, he says, that's too many characters. I want this. Because I don't need the parentheses, and if it's only one line, I don't need the return. So right now, this becomes much easier to read. There you go. I've replaced that big, huge for loop with just this little thing. Still may be unclear. I do not like anonymous functions. Anonymous functions, especially in an FP style, make things a little less clear. So I created an add1 function up above, list.map add1. It's very clear what's going on, right? Can you guess? Is it easier for everybody to guess what list is going to print out? Ah, I'm getting there. You ruined it. But yes, OK. This printed out that. This prints out that. Why? Ah, that's this. Avoid changing state and mutating data. We don't, in the functional style, we don't mutate data. Why? So, OK, some of you feel very confident, so I'm going to ask you, why don't we mutate data? Is it just one of those FP things like, tail call recursions? Nobody wants to venture a guess. Multi-threading in JavaScript? Listen, we're Nebraska JS, man. It's totally fair. Okay, but so here's why. Here's a couple of reasons. I'm not going to go through them a lot, but enforces options. This one I'm going to talk about. Easier to validate. So React state is immutable. You should treat state as if it was immutable. That's a very important distinction because it's not actually immutable. And the reason for that is if you change an object, object A equals object B now becomes false. If you add something to an object, or you change a variable inside of an object, that still evaluates to true. So you don't know whether this thing has changed without doing a deep compare. Most importantly, less brain power. For that reason, and because you don't have to worry about what's going on with all of my stuff. So here's what that looks like. I have options here. Look, I can just say list equals list.map. It's not that big a deal. I'm adding like a couple of characters. But if I don't want to change it, I don't do that. I just assign it to something else. I have options available to me in how I'm going to handle my array. So that's very cool. Okay. But what if we want to do multiple things at one time? How many of you only ever do one thing in your for loop? Like never. We do a lot of different things in our for loop all the time. So let's add one and then sum them. So look, add one, and then I'm going to reduce my list. So reduce, what reduce does is it basically lets you aggregate down an array, sums over an array, and basically does a sum. Or it can do an add, or it can do a group by, or it can do whatever you want to do. But val list.map, add one, then reduce it to sum. I get 20. By returning the array, instead of changing the array, I can just chain this stuff out. And I've actually written code recently that I had like 4 or 5 of these things. And you just put the dot on the next line. It's very readable. It's very easy to see what's going on. This right here is why I've started to really like the functional style, because this is a lot cleaner once you kind of grok the idea. This is a lot cleaner than the big for loops, the big monolithic code that sits everywhere. Then you get to this thing. Because it's easy when you're talking about arrays and map and pure functions and all of these things, but then functional programming gets into weird stuff like currying. How many of you have heard this phrase before? All right, here's what currying does. Currying, I have this function, let sum equal a plus b, or a comma b. I'm passing a and b in, it's going to pass me back the sum. Currying, in mathematics, again, it basically takes an array, or a function that takes multiple parameters and breaks them up so you can pass one parameter into each function. So this becomes this. Right? I don't know why you would ever do that. That's weird. But here's an example. Here's one of the reasons I use currying, even recently at work in code. So I have a list of buttons. This is easier to explain. Mine was a list of drop-downs, and you had drop-downs. So I've got a list of buttons that have a name, and they have a message associated with that button. That should be easy to, okay. On click, I have this dot on click, and I want to display the message associated with the name. How would I do this? So when you click the button, I'm going to fire an on-click event. I want to display the message associated. Well, in your on-click event, I've got to loop back over my buttons to figure out which button got clicked. Or I could add something to the DOM element, or there's a bunch of different ways to do it. They're all fairly more brain intensive. What I really want to do is this. I want to pass the index of my DOM element, my button, into the on-call, then I don't have to loop. I just, hey, my index is right there. But what does the on-click event handler pass me? Can I change the event handler? No, it's going to pass me event, no matter what I do. But I think we just talked about something that might fix my problem, right? I want that. So what you end up doing is, hey, I have a get on click event. And my getOnClick event is going to pass me back a function that has access to index. Now, I don't have time to explain this. Closures. All right, I got one. Who knows what a closure is? Who can articulate it nicely? Okay, that's, all right. No, okay, so here's in a nutshell, here's what a closure is. When this function, return function event message equals buttons sub index, when that function is created, JavaScript takes everything that's in scope for that object and packages it all up and hands it off. So I'm not returning just the function, I'm returning the function and the scope of that function. That's a closure. So what's in scope for that function? Index. So index comes back as part of it. Okay, so that probably didn't help you at all, but that's my explanation of what closures are. So now, on that onClick event, I'm creating a new function. You can get into performance conversations. I don't care. This is easier, so this is what I'm doing. Creating a new function. Now every time I click the button, I get exactly what I want. All right, so here's what I want to leave you with, because I'm right at time. I want to leave you with this idea that when you start writing functional style, don't take a React app and say, I need to convert this entire application to the functional style. I need to kill everything that I have, and now everything has to be immutable, everything has to be pure functions, because it's not possible. You can't write a web application in JavaScript that's purely functional. What you can do is start taking these little building blocks of your code and start applying this functional style. And I've given you just enough to make you potentially interested so you can go look at it. To clean up little pieces. Don't clean up the whole code base. Clean up this for loop right here. Or clean up this one other thing right here to make it a little cleaner, a little nicer and easier. All right, so that's me. Thank you guys very much. And if you've got questions or something, we can chat at lunch.